CAMTECH Gwalior is a multidisciplinary centralized training center under the Ministry of Railways. This center develops technical publications and manuals on various railway assets and provides training through seminars and webinars, thereby assisting the maintenance team in improving the reliability and efficiency of the system. This video is related to the maintenance and testing of lightning arresters (LAs) under the series of electrical assets maintenance in 132 kV to 27 kV conventional railway traction substations. This video includes the functioning of lightning arrestor or LA provided at 132 kV and 25 kV side and its maintenance activities including testing. Basic construction of lightning arrestor. The lightning arrestor comprises many nonlinear resistor blocks housed inside the porcelain housing. It is constructed in a way that is completely airtight to prevent moisture ingress inside the porcelain housing. Connection of lightning arrestor. Top terminal of LA is connected to the live circuit by jumper wire and the bottom terminal is connected to earth through a surge monitor having a counter and micro ammeter. In the case of LA provided at the main gantry for OHE feeders, a 25 kV line is connected to the top terminal of LA through a disconnector assembly. A circular metal grading ring is also provided along with LA to modify electrostatically voltage gradient for more than 42 kV voltage rating. Functioning of lightning arrestor. LA provides protection against overvoltage surges caused by lightning and switching operations in the traction distribution system. Under normal operating conditions of the system, the LA will have a very high resistance to earth and acts as an open circuit. On the occurrence of an overvoltage surge, the resistance of the metal oxide type LA decreases very sharply due to its high non-uniform voltage current characteristics. Hence, the overvoltage surge is safely diverted through a low resistance path to earthing. Again, it restores its resistive property after passing the overvoltage or switching surges. Location of lightning arresters. Lightning arresters are provided in TSS at these locations. Main gantry LA with disconnector. HV side LA with grading ring. LV side LA at TR secondary and capacitor bank circuit without disconnector. Voltage rating of lightning arrestor. These lightning arresters are available in various ratings. Maintenance of lightning arrestor. The periodic maintenance of lightning arrestor is carried out in the following schedules: half-yearly and annually. Half-yearly schedule. In the half-yearly schedule, do the thermal scanning. Annually schedule. In annual schedule, performs activities like checking the insulators, terminal connectors, earthing connections, check the healthiness of disconnector assembly and measuring IR value and leakage current, check for physical condition and functioning of indicators of the surge monitor, etc. in addition to half-yearly schedule activities. Safety precautions before maintenance. For the safety of equipment and personnel, ensure that switch off the power supply by the opening circuit breaker and isolation to be done by opening isolators, and then provide discharge rods at both ends of LA under maintenance and discharge the residual charges. After this, open the connection of the HV terminal of LA. And also ensure the use of personal protective equipment for safety such as electrical grade shoes, helmets, etc. Safety precautions for supply on condition activities and testing. Before performing the supply on condition activities and testing, ensure that take safety precautions and all connections are to be done correctly. Maintain safe working clearance during testing and use personal protection equipment. There are many activities that have to be performed during maintenance in supply of condition. Cleaning of porcelain housing of LA with dry cotton cloth for removing any dust and dirt accumulation. Check the tightness of terminal connectors, cable connections, and earthing connections. If found loose, then tighten with adequate torque. Check the disconnector assembly provided at main gantry for 25 kV OHE feeders for its healthy condition. If it is found broken, then investigate the issue and check LA for failure. Check the physical condition and functioning of indicators of the surge monitor. Testing of lightning arrestor. As per the maintenance schedule, these tests shall be performed at regular intervals mentioned in this table. Precautions before testing. While performing the tests, these precautions shall be followed. Insulation resistance test of LA. The main objective of this test is to know the condition of the insulation of LA. This is a DC voltage injection test method, and for this test, we require a 5 kV, 2.5 kV and 500 volt insulation tester. Steps for testing. Here we are conducting a test for HV to earthing only for 42 kV rated LA. So for this, first, open the connection at the HV side. Here we are conducting test for HV to earthing. For this test, connect the lead of the line terminal of the tester to the HV terminal and the lead of the earth terminal of the tester to the equipment earthing. After that, check all the connections and select the DC voltage level to 2.5 kV in the tester. Finally, the setup is ready to perform the test. Now on pressing the test button of the tester, 2.5 kV DC voltage is applied across the HV and earthing. As a result, leakage current will flow in the circuit, and the tester will measure this leakage current and calculate the insulation resistance value by the ratio of applied voltage and measured leakage current. Record the displayed value of IR and compare the value with earlier records or OEM recommendations. If found less, investigate the issue and rectify it. The same test to be conducted for the following combination. Testing data may be recorded in this format for further investigation and future reference. Measurement of leakage current. Perform this test in supply on condition and ensure all precautions for supply on condition. The total leakage current has two components. One is a capacitive leakage current and another is a resistive leakage current. The capacitive leakage current does not change significantly due to the deterioration of the voltage current characteristic of the nonlinear metal oxide resistors. The resistive leakage current is a sensitive indicator of changes in the voltage current characteristic of nonlinear metal oxide resistors. In resistive leakage current, the third harmonic is the largest component, therefore, it is the most commonly used for diagnostic indication of changes in the condition of metal oxide arrestors in service. Steps for testing. This test method is based on the third-order harmonic analysis with voltage harmonics compensation. Test kit is battery-operated and has a clamp on CT and a field probe. Connect the master earthing of the test kit to the earthing of LA. After this, clamp the wireless clamp on CT in a cable connecting the bottom of LA to earthing through surge monitor. Remember that connect clamp on CT before the surge monitor. One person shall hold a wireless field probe that is connected to the insulating rod and stand under LA and place the field probe near LA bottom part with taking all precautions. Then start the test, and the leakage current and their components and the harmonics in supply are measured by clamp on CT and field probe. This collected data is transferred to the test kit. After getting the data, the kit shows the total leakage current and the resistive component of leakage current and the most important third harmonic component of resistive leakage current. The value of leakage current shall be recorded and in case of abrupt variation or very high leakage current, the concerned lightning arrestor should be taken out from the service for detailed investigation. Testing data may be recorded in this format for further investigation and future reference. Thermography. Thermography is used to predict or identify defects and to rectify the same by carrying out preventive maintenance before in-service failure of equipment. Since analysis is based on the relative temperature of subcomponents instead of ambient temperature, therefore, images of the complete assembly should be taken. Checking should be carried out at the night time, and the concerned component shall be under low. Limit for temperature variation and duration for rectification of issue is given in the table. Testing data may be recorded in this format for further investigation and future reference.